IGC physics, we have to do the topic force on a current carrying conductor. So do you have any idea that how we can solve these equations and questions like this? That what does that mean by force on a current carrying conductor? For example, there is a conductor, okay? So that conductor, if we attach that conductor, the current place that conductor inside the magnet, that will carry a magnetic field, and because of the magnetic field will shows a force on that current carrying coil, okay? So we just have to deliver the explanation on force on a current carrying conductor. So we have any conductor, the current in that conductor, current is flowing, and we have to focus on the force on a current carrying conductor. So we have to consider the direction. We will use the Fleming left hand rule. Is it? Yes, Fleming left hand rule. So the force on a current carrying conductor is a fundamental concept in electromagnetism and is described by the Fleming's left hand rule. So here is a detailed explanation that when a current carrying conductor is placed in a magnetic field. Now this is a conductor, na? This is a current carrying conductor. So now that is placed inside the magnet, and that magnet produces a magnetism, okay? So this phenomena is the basis for many electromagnetic devices such as electric motors, okay? So you have to write this thing down. When a current carrying conductor is placed in a Are you writing?
Yes.
Okay. When a current carrying conductor is placed in a magnetic field, it experiences a force.
It experiences a force.
Yes. Okay. So in this, that force must have the direction. That current must have the direction, and that field must also has the direction. Okay. So look at the figure that is shown in the screen. Accompanying figure force on the current carrying conductor's wire when a current flows, that will describe the force on a current carrying conductor. So through a wire, it creates a magnetic field around a wire. So this is a wire. When it passes through the magnetism, it will induce a magnetic field around the wire, and this magnetic field interacts with the magnetic field of magnet, producing a force. So this current is also producing a magnetic field. This magnet is also producing the magnetic field. So they both will interact with each other. Okay. Magnet producing a force to act on a wire. Upward, this causes the wire to move upward. The Fleming left hand rule helps to determine the direction of magnetic force on the wire. The index finger points in the direction of magnetic field. Okay, this is an index finger that is pointing in the direction of magnetic field, thumbs directing the direction of force, and the middle finger direction gives the direction of current. Okay.
Okay.
And the three fingers are perpendicular to each other, and the force is maximum when current flows through the perpendicular. This is a positive point. Okay, when each finger is perpendicular, draw like make a Fleming left hand rule by your hand, then you will show that thumb is perpendicular to the index finger is perpendicular to the middle finger. So every finger is perpendicular to each other, and that perpendicular shows the angle is 90. So whenever there is a perpendicular making an angle of 90, the force is maximum. Okay. Okay, you have to write this thing down. Three fingers are perpendicular to each other.
As these fingers are perpendicular to each other,
The force is maximum.
force is maximum
when the current flows
and the current flows
perpendicular to the magnetic field.
perpendicular to the magnetic field.
Yes, and done. Now this is also written here, these points, okay? Force is maximum, current flows perpendicular to the field, no force, current flows parallel. Okay, when force is maximum, when the force will be maximum, when current flows perpendicular to the field. When there is no force, means zero force. When the current flows parallel to the field. Force is always perpendicular to both the current and the magnetic field. Force is always perpendicular to both and the current and the magnetic field. Did you get the point, Ayan?
Yes.
Any question?
No.
Okay. When a current flows through a wire, it creates a magnetic field around the wire. And this magnetic field attracts the magnetic field of magnet, producing a force to act on a wire. Did you understand this paragraph? When current flows in the wire, that wire is placed inside the magnet. That magnet has their magnetic field. Current wire is also producing the magnetic field. Both magnetic field will interact with each other. Okay? And they both will interact with each other. They will produce a force to act on the wire. Okay? So the direction of force on the wire can be reversed by reversing the current or by reversing the magnetic field. If you want to reverse the direction of a force, now this is a direction. So if you want to change the direction of force, then you should change the flow of magnetic field lines, or maybe you can change the direction of current. Now current is traveling from electron flow, negative terminal to positive. If you oppose the direction, that will be conventional current. Then the current is reverse current, and the field and the force will also be the reverse. Okay. And the next point that is highlighted here, if both current and the magnetic field are reversed at the same time, the direction of force remains the same. This is a common point. Look, if the both current and the magnetic field are reversed. Okay, look, this is the same picture. This is the same picture. Okay, that is in your front. That picture is in your front, and that is showing back. Look here, the current and the field direction is changed at the same time. Okay, can you make a Phalemonic left hand rule? First point it towards yourself. Point it yourself. No, that is not a left. Okay, yes. Put that finger toward yourself. Towards your. No, the middle finger. In which the direction of current. थंब को आप ऊपर करें ना, थंब को आप ऊपर रूफ की तरफ करें, ये वाली फिंगर को, हाँ बस ये देखें. अब आप एक काम करें, इसकी डायरेक्शन मेरी तरफ लेकर आए, अब घुमा कर मेरी तरफ लेकर आए, घुमाएं इसको, मैं अपने पीसी की तरफ लेके आए. हाँ, अब उसी मिडिल फिंगर को पीसी की तरफ डायरेक्शन करें उसकी. हाँ बिल्कुल ऐसे. अब देखें, अब आप देखें कि फोर्स की डायरेक्शन तो वही रही है. आप इसको पूरा घुमाएं, इसको घुमा के देखें कि यहाँ पे भी पहले फोर्स की डायरेक्शन यही है, फिर वापस फोर्स की डायरेक्शन यही है, लेकिन डायरेक्शन चेंज किसकी हो रही है? करंट की और मैग्नेटिक फील्ड की. हाँ, जब करंट की और मैग्नेटिक फील्ड की डायरेक्शन एट द सेम टाइम चेंज हो तो क्या चीज़ कांस्टेंट रहती है? फोर्स. क्योंकि आपका थंब वहीं पे है, आप करंट को चेंज कर रहे हैं, मैग्नेटिक फील्ड को चेंज कर रहे हैं, लेकिन फोर्स वही कांस्टेंट है. हाँ बिल्कुल ऐसे. गुड. Okay, the next thing is the magnitude of magnetic forces can be increased. Okay, if you want to increase the magnitude of a magnetic forces, increasing by the current, or mean you can increase the battery, you can increase the voltage. In that way you can increase the magnitude of magnetic forces. Increasing the magnetic field strength by using the stronger magnet. If you have a magnet that is much stronger to produce enough magnetic field lines, that will have a stronger magnetic field strength force. Okay, so increasing the length of a wire, for example, if you increase the wire, that will have a larger cross section area, and because of the larger cross section area, it will have more loops, more field lines, and the more force. Okay, any question from this page?
No.
Okay, did you understood each and everything?
Yes.
Very good. Okay, the loudspeakers and the headphones convert electrical signals into sound. So when we have any sound equipment, loudspeaker, headphones, earbuds, or anything, they produce electric signals, and they convert that electric signals into the form of a sound. How did they? This is an application of current carrying magnetic field. Okay, so the loudspeaker is connected to an amplifier that provides an alternating current. This alternating current flows through the coil, creating alternating magnetic field around it. And the alternating magnetic field interacts with the field of permanent magnet, causing a force to be exerted on the coil. So this is a loudspeaker that is connected with the amplifier. That amplifier provides an alternating current, means direct current, one path current. And this alternating current flows through the coil. We have a coil. This is an alternating current. Okay, this is alternating current, and this is the coil. Look here, this is a coil that round around an orange box. Okay, and next thing is through the coil are creating alternating current, magnetic field around it, and that is current flowing around a magnetic field coil. That is possibly know this, that will be induced a magnetic field. When the magnetic field is produced, the alternating magnetic field lines interact with the field of permanent magnet. So we have a magnet in between. This is a coil, and these are two magnets. So these two magnets have their own magnetic field, and that coil has their own magnetic field. These two magnetic field will interact with each other, and they will produce force, causing a force to be exerted on the coil. Both are going to exert force into the coil. So as the constant change in the magnetic field direction, the exerted force on the coil will constantly change the direction, causing the coil to oscillate. So when they putting a force, huge force into that coil will start vibrating. Okay, it will start oscillation, and with that of oscillation a sound is produces, electrical signals is produces. So the oscillation coil causes the paper cone to oscillate. That paper cone is start oscillating, and this makes the surrounding air to oscillate, creating a compression and rarefaction. Compression and rarefaction means this is compression and this is rarefaction, gap and without gap, and forming sound waves. Okay, this is the best explanation, which is explaining how the concept of current carrying conductor works on daily life example. So I use the example of loudspeakers. So that loudspeaker we use in our houses, in the school assembly. So this is the main function and the main working of loudspeakers. Okay, did you understood the concept of loudspeakers, Ayan?
Yes.
Can you explain one more time? What did you understood?
Yes.
Okay, explain. Like, you don't have to take a look from these notes. You can just tell the explanation you just understood in the class. Just explain in your own words. How you can say that loudspeaker is the best example of current carrying conductor?
So when an alternative current flows through the coil, by getting EMF to be induced in it through the magnet from the magnet, then as the then a force is then produced on it, and then when there's a constant change in the magnetic field direction, then a force will be exerted on the coil, which will make the sound to the coil to oscillate, and then it will pass through the paper cone, and then it will make the surrounding air, it will vibrate the particles in the surrounding air, which will cause sound waves.
Yes, very good. So basically in speakers, a coil of wire in a magnetic field moves in a response to an electric current, producing a sound. Okay.
Yes.
So next thing is like force on the charged particles in a uniform magnetic field. So what does that mean by uniform magnetic field?
It is a magnetic field that is continuous, it does not change.
Yes. So when a charged particles moves through a uniform magnetic field, it experiences a force, and that force is called a Lorentz force. I hope you heard this word before in your school, in your lecture. Lorentz, Lorentz force. No?
No.
Okay, कोई मसला नहीं है. Okay, so this is like the force. This is x is into the page and point is out to the page. So this is a current that is coming, and this is x means this is a uniform magnetic field. ये पेज पे लाइक एक आपको स्टैटिक है, ये मूव नहीं कर रहे, इनकी कोई एरोज नहीं है. ठीक है, एक यूनिफॉर्म मैग्नेटिक फील्ड है. अगर यहाँ पे जहाँ पे देखेंगे जैसे ही वो जो जो उनसे पाथ है वो टकराते हैं तो वो वहाँ पे बेंड हो जाती है, फिर वो स्ट्रेट लाइन पाथ बन जाती है और जो उसकी डायरेक्शन होती है उसे ज़रा वो चेंज हो जाती है. यहाँ पे आप देखें ना, ये आपको करंट की डायरेक्शन दिखा रही है, ये फील्ड की डायरेक्शन है और ये फोर्स की डायरेक्शन है. So negatively charged particle travels opposite in the current flow. Negatively charged particles moves perpendicular to a uniform magnetic field current into the page, and this interaction creates a magnetic force being exerted in the particle directed downward and particle to its motion. This force always acts on the particle at a right angle, causing it to move in the circular path. ये देखिए एक पूरे का पूरा अगर हम देखें तो एक राइट एंगल बन जाता है, तो वो वहाँ पे पाथ को कर्व करके सर्कुलर पाथ की तरफ ले जाती है. When the particle leaves from the magnetic field, it moves in the straight line. क्योंकि जैसे ही वो फील्ड लाइन के अंदर होते हैं ना तो थोड़ा सा कर्व पाथ हो, जैसे वो फील्ड लाइन को छोड़ देता है ना फिर वो स्ट्रेट लाइन में ट्रैवल करना स्टार्ट कर देता है. ठीक है, ये इलेक्ट्रॉन के बारे में था. अब पॉजिटिवली चार्ज पार्टिकल्स ट्रैवल्स इन द सेम डायरेक्शन एज द करंट फ्लो. जैसे करंट फ्लो ये नेगेटिव का बता रहे थे, ये पॉजिटिव का बता रहे हैं. अब पॉजिटिव में बिल्कुल ऐसे ट्रैवल करके एंड द पॉजिटिवली चार्ज पार्टिकल्स मूव्स परपेंडिकुलर टू अ यूनिफॉर्म मैग्नेटिक फील्ड डायरेक्टेड इनटू द पेज, एंड दिस इंट्रैक्शन क्रिएट्स अ मैग्नेटिक फोर्स एक्टिंग ऑन द पार्टिकल डायरेक्टेड अपवर्ड एट परपेंडिकुलर टू इट्स मोशन. वो डाउन आता है और वो अपवर्ड चला जाता है. ठीक है. When the particle leaves from the magnetic field, it moves in straight line because of the absence of magnetic force. क्योंकि अगर हमारी मैग्नेटिक फील्ड यूनिफॉर्म होगी तो मैग्नेटिक फोर्स तो ज़ीरो हो जाएगी, तो उसमें उसकी डायरेक्शन पेज के होते हुए तो वो सर्कल पाथ में हो जाती है. जैसे पेज से बाहर निकलती है वो स्ट्रेट हो जाती है. ठीक है. Okay, I hope you have much idea about the conductors and insulators. Okay. Yes. And then conductors are materials that let electron pass through them and conduct electricity. So the metals and the carbons are the best electrical conductors as the electrons are so loosely held to their atoms and that they can move freely between them. An electric current is the flow of these free electrons in one direction. Example, the conductors copper, silver and aluminium. So these are the best example of conductors in which electricity can pass through easily. Okay?
Okay.
So insulators are the material that hardly could conduct electricity at all because in the conductors all the particles are tightly packed together. In the conductors all the particles have a larger distance between them. So their electrons are tightly held to atom and are not free to move. So there are no free moving electrons to form an electric current when the battery is applied. So what the transfer of the current electrons should be free moving electrons. Okay?
Okay.
And the next thing is added. No, this is the concept. For example, this is an insulating stand. Okay, it has both positive and the negative. This is concept of induced charges. Okay, charge that appear on an uncharged object because of a charged object nearby are called induced. For example, there is a rod that is induced, that has a charge, that is electron. When you near that charged object to the uncharged, this one is uncharged, this one is charged. So when you place charged object to the uncharged, it will shows an induction. Induction means rather attraction, rather repulsion. So all the positive will be attracted and the negative will be repel. Okay. And this is also the very interesting concept. This is a wire earthing. Okay, we attach earthing wire. All the electrons will travel here and down to the earthing wire because they are just showing a repulsion because of that rod. And this is the insulating stand only with the positive charges. Okay. And the next thing, this is known as that is a gold leaf electroscope. This is a method. Okay, this is a practical. We have a metal ball, we have insulator, and at the last of metal rod we have a gold leaves. This is a very interesting practical. In this we have a metal ball that has a positive and negative electrons. When we place that rod near to it, it would attract it positive charges and the negative will be go down and these gold leaves will repel each other. If they have same charges, they will repel. If they have like charges, they will attract. Okay.
ठीक.
Now this is again the, and this is an example. Remember this example we did? A negatively charged rod is held close to one side of the metal sphere. The other side of the sphere is earthed. Which diagram shows the distribution charges on the metal sphere? Which one?
ये हो के
A, B, C or D? आपको कौन सी लग रही है? इसमें रॉड को इस के पास लेके जाया गया है जिसमें दोनों चार्जेस थे. वो अनचार्ज था, रॉड चार्ज था, रॉड के ऊपर इलेक्ट्रॉन्स थे, और उस मेटल बॉडी के पास पॉजिटिव भी थे, नेगेटिव भी थे. तो जब उसने पॉजिटिव अट्रैक्ट किए तो पीछे नेगेटिव रह गए, और नेगेटिव तो अर्थ वायर के साथ अटैच है, वो सारे डाउन चले गए. वेरी गुड, डी वाला करेक्ट ऑप्शन है. वेरी गुड, एक्सीलेंट वर्क. इज देयर एनी क्वेश्चन इन दिस आयान? So this is
no.
So everything is clear here?
Yes.
So far so good?